Time for a quick introduction to a number of basic components in Python. There are a variety of kinds of data. We've seen integers and strings so far. So there are numbers, not only integers, but also things with decimal points. We've seen character strings. There are also lists in square brackets here. Could be integers, could be strings, or any mixture. There's a special datum none, which means nothing. We've seen functions in our example program. The basic syntax is to have a name of a function that you're calling, parentheses, and possible parameters inside. There's a number of functions built in to Python. Let's look and play here. One function built in is the type function. For instance, what is the type of 2? Well, the class is the same as the type, and it says it's an int, short for integer. A number of things are abbreviated in Python. Let's try another one. Oh, here's a handy thing. If you click on a line and then hit enter, it repeats. What if I change it to 1.25? This is class float. It's a different sort of object than the integer. The reason for the name float we'll get to much later. It has to do with scientific notation. And we've also dealt with strings. So let's look again. Copy, because I'm lazy. Let's say hello. Okay. And we see this is a str, short for string. I also illustrated a list. Let's try that. Type. List goes in square brackets. I don't know, 1, 2, 7 or something. Close parentheses, as we have at the end of all functions. And this is actually spelled out. This is a list, in this case, of numbers. Other functions, rather than finding the type of this list, I could find its length. Len is short for length. And if I evaluate that, you see that it's 3. There are 3 items here. Also, you'll see that the string here is a sequence of 5 characters, and that we also see that from the len function. Some functions have no parameters. Here, this will create a new list. And you see the square brackets with nothing in between them makes an empty list. It's also possible to have functions with multiple parameters. Max is short for maximum. 3, 5, 2, minus 7, 9, something like that. Oh, let's not make it be 9. And it says the maximum is 5, which is true. Some names serve to convert one type to another. For instance, remember, str is the type for string. If we give it a number, like 23, what does it do? It gives us back something in quotes. That's a string, not a number. Conversely, int is the type for numbers, or integers. If I give it a string, like 56 or 567, the data in here is a string, not a number, but there is obviously a closely related number, and this conversion will give it to us. Let's go on and look at some more arithmetic. We've already seen that we can do things like 2 plus or 3 plus 5, or more additions, plus 7 plus 9, whatever. Okay, and that comes out to 24, and subtractions. Now let's see, how do we do multiplication? You might remember from grade school something with an x. Let's try 9x2 and see what happens. Oops, this red syntax error is telling you that the Python interpret cannot interpret this, and it's even telling you where it had trouble. The problem here is that the symbol for multiplication in Python and most other programming languages is the asterisk. So 9 times 2 is 18. Another thing is that we can do something like this. 2 plus 3 times 5. Think what that's going to be. If you're thinking it's going to be 25, you're wrong, because Python understands the normal precedence rules for arithmetic. Multiplication is done before addition. This is 2 plus 15. We can also mess with precedence using parentheses. Let's change this around and write 5 times parentheses 3 plus. Okay, now I'm going to hit return and see what happens. Notice I didn't get an answer. It didn't go back to the left margin. Why? Well, Python is smart enough to realize that I've got an open parenthesis here. I can't be finished. All right? So if I put the 5, still not finished. If I put the second close parentheses, notice that it shows that they match, and now it's happy. And we get 5 times 8 is 40. I haven't talked about division yet. Let me look at the section on division and remainders. First of all, we can try what's being illustrated here. If I do 9 slash 2, slash is often used for division, and we get 4.5. 7 divided by 8 is 0.875. Let's look at this a little more closely. If you go back and think about your earliest grades in school, you might say something like 14 divided by 4 is 3 with a remainder of 2. We do everything with integers. And those are also legitimate ways to think of division. We've got multiple possible answers associated with division. If we divide 14 by 4, we can get a decimal, or we can think of the integer quotient, and there is the remainder associated. There's 3 different numbers. Python handles that by having 3 different symbols. The slash, as we saw, gives a decimal answer. Now, if we want to do integer division, there's a slight variation. A double slash gives me integer division, as in the grade school version. 14 divided by 4 is 3. Of course, there's also a remainder of 2. And we haven't taken care of that yet. And here we really run out of obvious symbols, but this is one that's used by many programming languages. We adopt the percent sign to mean remainder. This is the remainder when dividing 14 by 4. That's the last number associated with division. Here we get our 2. So for division, if you want a decimal, use the slash. If you want an integer, as in grade school, then it's slash slash. And if you want the remainder, it's the percent sign. You might not think this remainder is very useful, but in fact, it will come up many times to be useful.